So we are continuing with solving systems. By the way, systems are also called simultaneous.
We're not graphing right now, are we?
No. And we're using algebra, algebraic methods, but today, instead of doing substitution, we are going to do what's called the elimination method, which is sometimes called the addition method, depending upon who you're talking to. But the concept's going to be the same regardless.
The addition method?
Addition/elimination method. It's going to be the same process. All right. Here's the idea with elimination. We want to combine the equations into one such that a variable cancels itself. That's our goal. Elimination has an advantage over substitution in that initially you can avoid fractions. I mean, you might get fractional answers still, but you can initially avoid it. Yes?
What's after algebra?
Algebraic, elimination, addition. Yeah. All right, so here's going to be our example. And initially what I'm going to do is actually solve it with the substitution method, and then we'll see how it works out with this different method. So we'll have 2a plus 3b equals 12, and 5a minus b equals 13. So if we were going to solve this one by substitution, our method from before, what might we do? Okay, so choose an equation. Which one?
5a minus b.
Okay, so we'll take that 5a minus b, and we're going to solve it for what? Solve it for b? Okay, that's good. So we'll subtract 5a. And we get negative b equals 13 minus 5a. And then what do we need to do? All right, and now what will we do with this b? Yeah, I'll substitute it in there. So I have 2a plus...
Bless you.
Thank you, Nate Dog. Yeah. He's a puppy. All right, we distribute that. We're in a competition. I guess he's winning.
You don't want to remind me of how you do that? Remind me when you now I forgot the name Mooney.
All right, so we get a is 3 anyways. After that, we combine our like terms, we add the 39, and we divide by 17, we get a is 3. Then we take that a, and we put it back up somewhere in one of these equations to get b. So I'm just going to choose this equation right here. So I do 5 times 3 minus b equals 13. I get 15 minus b equals 13. Subtract my 15, get negative 2, and then divide by negative. So my answer is 3, 2 by substitution method. Now we're going to do it all again. Okay, but we're going to do the new method. Any questions on how we worked through that?
Wait, you got e equals negative 13 plus 5a now. Why are you getting b again? That's what I don't understand. Because you didn't actually
Right here, we we're solving for b so that we could replace it up into here via the substitution method. That's what you did all yesterday. Okay? Now I want to be able to copy that, so I'm getting rid of that. So you know what? I could have, I see what you're saying. I could have taken this 2 and put it right here, and that would have been way faster. And you're absolutely right. I could do b equals negative 13 plus 5 times 2. Yeah, that would definitely be way faster. I should have done that. Anyways, any questions on substitution method there? Just a quick rehash. We good? Okay. All right. Now let's do it elimination method. We should get the same answer. And the answer was 3, 2, I believe? Yeah, 3, 2. We should get the same thing. Now, elimination method, I want all the variables to line. Remember how I said on your Casio calculator yesterday, if we get our variables in order, all on one side and then equals a number, if we can put it in and it'll solve it for us. We want it in that order. So we get it in alphabetical order, all our equations, and we set it equal to a number, like this setup. To do elimination, we line up our variables, and now we want to add these equations so that a variable cancels itself. So just watch for a second if I add them right now. Do you see this is what I'd get if I just straight up add them the way they are? Did a variable cancel? No. Okay, so that's not going to help me. I need a variable to cancel. So I could cancel the a's or the b's. I'm just going to choose one. I'm going to choose the b's. And in order to cancel the b's, what do you think needs to be in front of here? A 3. So I'm going to take both of these and rewrite them. I don't need to do anything to the first one. But I'll take this second one and I need to multiply it by a 3 to get that. So 5 times 3 is 15. Negative 1 times 3 is negative 3b. And 13 times 3 is 39. And now when I add them, I get 17a equals 51, which we did get that in our substitution method at one point. Then I divide by 17, and I get my 3. Now I'll take that 3, and I'll substitute it into one of these up here. And just for the sake of argument, I'll substitute it into the first one. So I'll have 2 times 3 plus 3b equals 12. I'll subtract my 6, which I just get 6 when I do that. I divide by 3, and I'll get my 2. 3, 2, just like with substitution. So no matter which method we happen to be using, we should get the same answer. And of course, we can check graphically on our calculator or with our solver. All right, let's try number next.
Number next.
Yep.
Multiply the whole equation by 3. So that the b could have 3 in front of it and cancel out with the other b.
Now this one is a tricky one. I want to add my equations so that one of the variables cancels. You can choose whichever variable you want. It makes no difference. Alright, so let's choose a variable. Which variable do you want to get rid of when we add? Huh? The y. Okay, sure, the y. The y is a good choice because they're opposite in sign. So when I add them, they could cancel. Well, right now, they're not going to cancel. So in order to get these to add so that they cancel, I need the least common multiple. Well, what is the least common multiple of 2 and 3? 6. So I need a 6. So I'm going to multiply the first one by 3 and the second one by 2. Because 3 times 2 is 6. 2 times 3 is 6. Alright, so when I multiply, what do I get for the first equation?
15x minus 6y equals negative 57.
And then when I multiply the second equation by 2, I get 4x plus 6y equals 0. And now notice what happens when I add. The y's go away.
So the one you multiplied by 3, the other you multiplied by 2.
Then I divide by 19, and what's negative 57 divided by 19?
Still equals 0. Negative 3.
Did I make a mistake?
It's not supposed to be equal.
It's supposed to be, oh, yep, negative 3, yep. I didn't do the one I thought I did. Alright, what do I do with that 3? Yeah, and I can choose whichever one I want. I'll just choose the second one. So 2 times negative 3 plus 3y equals 0. So negative 6 plus 3y equals 0. Add the 6. Divide by 3. So my final answer, negative 3, 2. Now notice how these line up. I need them to line up. X, y equals a number. So here's my next system. Now we're going to solve this system with elimination, but I want you to notice, is this lined up correctly? No. I need all the variables to one side to do elimination. You with me? This one would actually be better with substitution, because I could just, this is already solved for y, so why not take that stuff and put it right down there, right away? That is by far the fastest method to solve this one. But we're practicing elimination, so we won't do that. So we need to add the x to the other side. So I'm going to get x plus y equals 4, and this other one just stays the same. Now I choose a variable to eliminate. Which variable do you want to eliminate? The y. I'm going to eliminate the y's. Now, they have the same number in front of them, but they are opposite in sign. So when I add them right now, I'll get 2y. I want them to actually cancel. So I'm going to multiply one of these equations by negative 1, and it makes no difference which one. I'll just multiply the top one by negative 1. So I get negative x minus y equals negative 4, and then I have 3x plus y equals 6. So the basic concept with elimination is to eliminate a variable, they have to have the same number, but opposite in sign. So this one was 1, so when I add down, I get 2x, the y's cancel, and then I get right here a 2. I divide by 2, I get 1. I take that 1 and I'll substitute it in. I'll just substitute it into that first one. So y equals 4 minus 1. So y equals 3. So my final answer is 1, 3. And if I wanted to check that, I would put it into both equations in order to check. Don't forget that. That's not something that's popped up in your homework as of yet, but it is something that will pop up on a quiz where I give you the answer and I ask you, well, is that actually an answer or not? I'm going to do 2 more that work out, and then I want to show you a couple that do not work out. Don't be afraid of large numbers. You do it the same way. Don't be afraid of decimals. You do it the same way. In fact, just a trick with decimals, I'm not going to do this right now, but if you really don't like decimals, you see, if I wanted to move this decimal point over one spot, I could just multiply all of this by 10. And that would move that decimal point over so we don't have decimals anymore. Okay? But I don't actually need to worry about that in this case. I'm going to eliminate the x's. So, I need them to have the same number, but be different in sign. So, I can multiply this second fraction, or this second equation, by -2. So I get negative 20x minus, this will be 15 now, equals negative 160. And this equation I don't need to multiply by anything. Then when I add down, the x's cancel, and I get negative 10y equals negative 40, and y equals 4. I take that 4, and I'll put it into the most convenient equation. That's going to be this first one. So 20x plus 5 times 4 equals 120. So 20x plus 20 equals 120. Subtract the 20. Divide by 20. And my final answer, 5, 4. So easy, an Algebra 1 student can do it. And you did, right? You did this in Algebra 1. We might have forgotten we did it in Algebra 1, but we did. Any questions? Could we do this by substitution method? We could. And I'm going to show you why we wouldn't want to. You do not have to write this down, but I want you to see, because that would be a good question, like, what is the strengths and weaknesses of each system for solving. So let's say I solve this one for y. So I get this. This one doesn't illustrate it very good.
Negative x.
Yeah, negative. So actually this is not going to accomplish what I want. So I'm not going to bother, never mind. I'll use a different one to show you. Why not? Alright, let's do one that doesn't work out. This one does not work out. So I want you to see what happens. Alright, so which variable do you want to eliminate? Okay. And so I need the same number in front. How do you want to get that same number? Yep. Now, I just want you to note, I could divide the first one by 3 and get something. So sometimes that's a good method. So we'll multiply this second one by 3. So I get negative 9x plus 3y. And the reason we can do this is, with an equation, we can, as long as we do the same thing to both sides, pretty much anything's legal. So if I multiply everything by 3, everything's legal. The cops won't get you. Now notice, these are going to eliminate. But everything eliminates, and I get 0 equals 0. Everything's gone. If that happens, we have infinite solutions, and this is a dependent system. So if that happens, and you get, whenever you get some number equals that same number, that's an infinite solution case. So the opposite of that would be some number equals a different number. That is a no solution case, which is actually what we'll do next. And actually, as confusing as this might be, I always think yay if this happens, because that means my work's done. And I don't have to go any further. Now we'll do one where we get a no solution. This is our system. Oops, I didn't mean to have two y's there. This, that should be an x, 6x. All right, which variable do you want to eliminate? Okay, we can eliminate y. They are not different in sign. So I will multiply the second equation not by 3, but by -3, so that I get opposite sign. So I'll get -6x plus 9y equals -18. Then I have 6x minus 9y equals 9. That's this equation, just copying it over. And then I eliminate, and I get 0, and a 0 equals -9. Well, that's not true. Remember from this side I said if I get a number equals a different number, no solution. So 0 does not equal -9, so no solution. And this is an inconsistent system. I did all that work for nothing. Now, what are some uses of this? There's lots of uses for this. I'm going to tell you one of the more fascinating uses of solving systems. There's actually a system of solving linears that's called simplex, and one of its big uses is to figure out how to manage traffic or manage lines. And people do get paid decent money to set up the system, solve it, and you know when a company has done that because whenever you go to the building, or in the building or in the traffic, someone's done that and they've solved the system, and no matter the time of day, it always flows real nice. You can tell when they haven't done that because it's always a big mess, and you know people are honking their horns, or there's a big lot of people and the line just doesn't seem to move. That means that company did not invest in hiring someone to do that, and they're bonobos. All right, so we're going to wrap up this section and practice. Let's practice. So we will stop my recording.